Welcome back. In this lesson, we're looking at AI use cases in manufacturing. AI/machine learning educational explainer. Now let's look at introduction. Artificial intelligence is becoming a major force in modern manufacturing. Factories are no longer only using machines, sensors, and automation, they are increasingly using data-driven intelligence. AI can learn from production data, machine signals, quality images, maintenance logs, supply chain events, and operator feedback. This helps manufacturers improve uptime, quality, productivity, safety, sustainability, and customer responsiveness. But AI in manufacturing is not one single technology. It includes predictive models, grounded knowledge assistants, and AI agents that can coordinate complex industrial work. In this video, we will understand AI use cases in manufacturing through a simple 3-bucket framework. Now let's look at what this video covers. In this video, we will first understand why AI matters in manufacturing. Then we will look at current AI trends shaping smart factories and industrial operations. After that, we will group manufacturing AI use cases into 3 practical buckets. The first bucket is AI and machine learning for prediction. The second bucket is RAG, or Retrieval Augmented Generation, for grounded answers. The third bucket is agents for orchestrated work. Finally, we will go through one slide on each major manufacturing use case and end with a practical recap. Now let's look at current trends in manufacturing AI. Several important trends are shaping AI adoption in manufacturing. Manufacturers are investing in AI to manage uncertainty, improve performance, and accelerate smart manufacturing. Predictive maintenance, computer vision quality inspection, demand forecasting, and process optimization are becoming common AI priorities. Generative AI and RAG are emerging as tools for maintenance troubleshooting, SOP guidance, engineering knowledge, and workforce support. Agentic AI is becoming important because factories involve many multi-step workflows across machines, operators, quality teams, maintenance teams, suppliers, and ERP systems. Physical AI, digital twins, robotics, edge AI, and AI governance are also becoming important parts of the manufacturing AI roadmap. Now let's look at 3 buckets of manufacturing AI use cases. A simple way to understand AI in manufacturing is to divide use cases into 3 buckets. Bucket 1 is AI and machine learning for prediction. These use cases predict failures, defects, demand, yield, safety risks, and energy consumption. Bucket 2 is RAG for grounded answers. These use cases use trusted manuals, SOPs, engineering documents, quality standards, and maintenance history to generate source-based answers. Bucket 3 is agents for orchestrated work. These use cases coordinate tasks across people, machines, systems, workflows, approvals, and follow-up actions. Now let's look at use case 1, predictive maintenance and asset failure prediction. Predictive maintenance is one of the most important AI use cases in manufacturing. AI models can analyze sensor data such as vibration, temperature, pressure, current, speed, and runtime history. The goal is to predict when a machine or component may fail before the failure actually happens. This helps maintenance teams plan repairs during scheduled downtime instead of reacting to sudden breakdowns. It can reduce unplanned downtime, improve asset reliability, and extend equipment life. For manufacturers, even a small reduction in downtime can create significant operational and financial value. Now let's look at use case 2, visual quality inspection and defect detection. AI-powered quality inspection uses computer vision to detect defects in products, parts, packaging, or assemblies. Cameras capture images from the production line, and AI models identify scratches, cracks, dents, missing parts, wrong labels, dimensional issues, or surface defects. This is useful when manual inspection is slow, inconsistent, or difficult at high production speeds. AI can help catch defects earlier and reduce the cost of poor quality. It can also generate quality data that helps teams understand recurring defect patterns. The result is better quality control, less rework, and more consistent customer satisfaction. Now let's look at use case 3, process optimization, yield prediction, and scrap reduction. Manufacturing processes often depend on many variables such as temperature, pressure, speed, material properties, humidity, operator settings, and machine conditions. AI models can study these variables and identify which combinations lead to better yield and lower scrap. This is useful in industries such as chemicals, semiconductors, pharmaceuticals, automotive, food processing, and electronics. The model can predict when a batch or process is likely to go out of specification. It can also recommend better process settings for quality, throughput, and cost. This helps manufacturers move from trial and error improvement to data-driven process control. Now let's look at use case 4, demand forecasting and production planning. AI can help manufacturers forecast demand more accurately. Models can analyze historical sales, seasonality, customer orders, market signals, promotions, inventory, and supply chain constraints. Better forecasting helps production planners decide what to produce, when to produce it, and how much capacity is needed. It can reduce stockouts, excess inventory, rush production, and missed customer commitments. AI can also support scenario planning when demand changes quickly. This use case connects manufacturing with sales, supply chain, procurement, and finance. Now let's look at use case 5, energy optimization and sustainability prediction. Energy cost and sustainability performance are becoming important manufacturing priorities. AI can analyze energy consumption, machine utilization, production schedules, weather, building systems, and process parameters. It can predict energy demand and identify opportunities to reduce waste. For example, AI may suggest better equipment scheduling, compressed air optimization, heat recovery opportunities, or energy-efficient process settings. This helps reduce cost while supporting sustainability goals. Manufacturers can use AI to improve carbon visibility, resource efficiency, and environmental performance. Now let's look at use case 6, RAG for maintenance troubleshooting and technician support. Now let us move to the second bucket, RAG for grounded answers. Maintenance teams often depend on machine manuals, service records, spare parts catalogs, troubleshooting guides, and historical work orders. A RAG assistant can retrieve the most relevant information and generate a grounded answer for a technician. For example, a technician may ask why a machine is overheating or what steps to follow for a specific alarm code. The system can respond using approved documents and previous maintenance history. This reduces search time, supports faster repair, and helps less experienced technicians work more competently. Now let's look at use case 7, RAG for quality, compliance, and SOP guidance. Manufacturing quality teams deal with SOPs, inspection plans, control plans, specifications, audit records, deviation procedures, and regulatory requirements. A RAG assistant can help users quickly find the right rule, procedure, or quality standard. For example, an operator may ask what inspection step is required for a specific defect type. A quality engineer may ask which SOP applies to a nonconformance or customer complaint. Because the answer is grounded in approved source documents, it is more reliable than a generic response. This improves consistency, audit readiness, and compliance support. Now let's look at use case 8, RAG for engineering knowledge and product design support. Manufacturers manage large volumes of engineering knowledge. This includes drawings, specifications, bills of material, change records, test reports, design standards, and lessons learned. A RAG assistant can help engineers find relevant design knowledge faster. For example, it can summarize past design issues, retrieve approved specifications, or compare change history across product versions. This can support faster root cause analysis, better design decisions, and reduced rework. It also helps preserve institutional knowledge when experienced employees retire or move roles. Now let's look at use case 9, RAG for supplier, procurement, and supply chain knowledge. Manufacturing depends heavily on suppliers, materials, contracts, lead times, quality certificates, and logistics documents. A RAG assistant can retrieve supplier agreements, quality requirements, purchase specifications, approved vendor lists, and shipment documents. It can help answer questions about supplier performance, material requirements, delivery rules, or contract terms. This is useful for procurement, planning, supplier quality, and logistics teams. The benefit is faster access to trusted supply chain knowledge. It also helps teams make better decisions during shortages, delays, or quality issues. Now let's look at use case 10, agents for maintenance work orders and spare parts coordination. The third bucket is agents for orchestrated work. A maintenance agent can monitor alerts, create work orders, check equipment history, suggest troubleshooting steps, identify spare parts, and route tasks to the right technician. It can also check spare parts availability and escalate if a critical part is missing. This turns predictive maintenance insights into coordinated action. Instead of only saying that a machine may fail, the agent helps organize the next steps. Human approval remains important, especially for safety-critical equipment and production-impacting decisions. Now let's look at use case 11, agents for production scheduling and shop floor exception management. Production scheduling is a complex manufacturing workflow. A shop floor agent can monitor orders, machine availability, material availability, labor constraints, changeovers, quality holds, and downtime events. When an exception happens, the agent can suggest schedule adjustments and notify the right teams. For example, if a machine goes down or material is delayed, the agent can help find an alternate plan. It can coordinate with ERP, MES, maintenance, procurement, and planning systems. This improves responsiveness and reduces the time spent manually chasing updates. Now let's look at use case 12, agents for quality nonconformance, CAPA, and root cause workflows. Quality nonconformance management often requires many steps. An AI agent can collect defect details, retrieve related SOPs, summarize inspection data, create a nonconformance record, suggest possible root causes, and route the case for review. It can also support CAPA workflows, where teams define corrective and preventive actions. The agent can track due dates, follow-up actions, evidence, and approvals. This helps quality teams move faster while maintaining control and traceability. The goal is not to replace quality judgment, but to reduce manual coordination and improve consistency. Now let's look at use case 13, agents for supplier disruption and procurement response. Supplier delays and material shortages can disrupt manufacturing quickly. A supply chain agent can monitor supplier updates, open purchase orders, inventory levels, shipment status, and production impact. If a risk appears, the agent can identify affected orders, suggest alternate suppliers, draft supplier communication, and escalate to planners. It can also prepare a summary of impact on production, customers, and inventory. This helps teams respond faster to supply chain disruptions. In manufacturing, speed and coordination matter because one missing part can stop an entire production line. Now let's look at use case 14, agents for digital twin and autonomous factory operations. Digital twins and agentic AI can work together to support more advanced manufacturing operations. A digital twin is a virtual representation of a machine, process, production line, or factory. AI agents can use digital twin simulations to test scenarios before changes are made in the real factory. For example, the system may test a new production schedule, process setting, or maintenance plan virtually. This can help teams optimize throughput, reduce risk, and improve decision-making. Over time, this can support more autonomous and adaptive factory operations, with humans supervising important decisions. Now let's look at final recap and closing. Let us recap the main idea. AI use cases in manufacturing can be grouped into 3 practical buckets. AI and machine learning for prediction help predict failures, defects, demand, yield, safety risks, and energy consumption. RAG helps teams get grounded answers from trusted manuals, SOPs, engineering documents, quality standards, and supplier records. Agents help orchestrate complex workflows such as maintenance, scheduling, quality nonconformance, supplier disruption, and digital twin operations. Together, these use cases show how AI can improve reliability, quality, productivity, sustainability, and decision-making in manufacturing. To wrap up, here is the key takeaway. You now have a structured overview of AI use cases in manufacturing. Review the core ideas, connect them to examples, and revisit concepts like introduction, what this video covers, current trends in manufacturing AI when practicing. If you can explain the idea in your own words, you have really understood it.